Alrighty, hello everyone, and welcome to TLMI's Platinum Sponsor Lunch and Learn presented by Baldwin. For the past 90 years, TLMI, a member-driven association valuing community, insight, and advocacy, has helped the tag, label, and packaging industry by providing opportunities for members to network and learn. Today, we continue that tradition by hosting another Platinum Sponsor Lunch and Learn, presented by John Cusack, Business Development Manager for Baldwin Vision Systems. John helps define and bring to market game-changing products and services for the print industry. And with that, John, the floor is yours.
Thanks, Jack. I'm going to just try to share my screen here then, and I guess we'll get into it. Try that one more time. Oh, technical issues. Second. Okay, at this time. And okay, I think we should be there now. Look good?
Yep, we see it.
All right, excellent. Okay, thank you everybody for joining. Thanks for the introduction, Jack. So today I'm going to be talking a little bit about inspection, a product called the PQV, and a new enhancement of that product that we've done, which is our Wizard IQ, which is essentially our fourth generation of the PQV for labels inspection. So I'm imagining that there's a little bit of a spread of various people on the call. Some people probably are very familiar with inspection technology and maybe even the PQV. And there's probably other people that are probably, just looking to learn a little bit about what inspection is and some of the benefits that type of technology can bring. So I'll try to, jump around a little bit, go deep here and there, but also just kind of keep it at a high level as well. So it'll be a little bit of a mix. All right. So I guess what I'll do is just quickly just walk through the outline here. So I'm going to start off by giving you a little bit of a introduction to Baldwin, sort of the background of who we are and the different technology companies that kind of have come together to bring in a PQV. Pose some questions. Maybe there are things that you already have kind of joined today to learn about, but kind of what does a user want from 100% inspection technology? Sometimes that's going to be very unique, but I think in general, a lot of you guys have very, very similar needs. And maybe I'll just talk through some of those concepts and kind of talk about how inspection can actually, make those differences. I'll do a little intro to the PQV itself, and then the Wizard IQ, which is that enhancement that we've made to the platform. And then finally, I'll kind of just do a quick overview of the full PQV workflow. And the reason I want to do that is that I think everybody probably listening here knows about inspection technology. They understand, at various levels what inspection technology is about, what it does. But there are also other companion products and tools that come with our inspection technology that allow you not just to find issues when they happen, but also how to manage those issues in your workflow. So, cataloging the events in a database, being able to review the data and make quality decisions, or maybe really business level decisions about what material you want to remove from your workflow or take out of the finished product that you ship to your customer. So again, just kind of talk through that as well, so you get the full view. All right, so we'll just talk very quickly here about Baldwin. And so basically Baldwin Vision Systems is a coming together of four different inspection systems companies: Verification Systems Limited and PC Industries, very heavy in the labels industry historically, and in high-end kind of pharmaceutical, security, banknote type of inspection even. And then we also have QuadTech and Vigitech, and their inspection systems that came from more wider format printing applications like flexible packaging, as an example. Baldwin Vision Systems was kind of set up, or it was kind of built, put together back in about 2018, so about 5 years in now. And one of the things that we've been doing over those 5 years is just trying to take the best of all the systems and all of the IP and know-how that we've got, and try to put them into our key product offerings. And the perfect example of that here today will be the PQV. So with all of that history and background, we've got a lot of experience generally, but quite a lot of experience in the labels segment here as well. Okay, so those questions. So what do we want to get out of today? I think we want to probably look to improve our quality. We might want to, reduce our risk or exposure or potential exposure. Maybe we want to simplify the use case of the inspection systems we have today. Maybe it's a drive towards sustainability. And I'm going to talk a little bit more about sustainability in particular, because I think it's a topic that's come up a lot. And the nice thing about sustainability is you kind of become more sustainable by implementing things that make you more efficient, things that allow you to use less energy. And they're all things that ultimately are better for your business. So, being sustainable isn't just like a badge or, a tagline. It really is something ultimately that is coming from material benefits that your company is going to gain from this type of technology. And, to be honest, it's probably a combination or permutation of all of the above. Right. So just to very quickly maybe kind of go back through the list, right, for kind of maybe the newbies, or maybe people are more kind of into what does inspection potentially offer me. So an inspection system is going to find variations in your workflow. So if you have a print job you've set up and you're running and something starts to go wrong, if your color starts to change, if your register starts to go out, if ink starts to disappear, an inspection system will detect that. And why is that important? It's kind of obvious, right? You need to be able to know you have problems so that you can take immediate action and try to minimize the impact of the issue. But then also you want to be able to find the defective material that is now in your workflow so that you can take corrective action through your converting process. So ultimately you do two things. You improve your internal quality by limiting the amount of waste you generate from the get-go, but then also you have the option on the back end to remove defective material to ensure that your outgoing quality levels are at the levels your customers expect. All that is sort of risk mitigation too, right? So again, some people will buy inspection systems because they have a very demanding customer that expects them to inspect their product. Okay, it's a very simple decision in that case, but it may be that you've had a bad experience in the past where some of your work has got into the market and there has been an issue and there's been a recall or customers demanding rebates. So, it can impact your standing in the market, your brand, your own personal brand, not the brand owner's reputation, but yours. So, there's a lot of risks that can be mitigated by this type of technology. And then for people who are much more familiar and maybe have long-standing experience with this type of technology, what people probably have found over the years with older generations of inspection technology is that they can be quite complex to use. They're not very simple. The use case can be difficult. And there's a lot of tools that these products have on paper, but they're very difficult to implement. They're either very time consuming or they're very complex to use. And maybe operator training isn't where it needs to be, or maybe you simply just don't have the time to use those tools. So you're not getting the best out of your system. I think that's one of the big things around the Wizard IQ that I'll be talking about, is just how it simplifies things for an operator, how it essentially lowers the barrier of entry for anybody to not just use an inspection system, but to use very powerful aspects of an inspection system too. And then, like I mentioned, around sustainability, if you can improve your quality, if you can minimize the amount of waste that you're producing, if you can, basically up the efficiency of your equipment, if you can find waste in your process faster because you can track it more easily, that's all efficiency, and efficiency can lead to sustainability. Okay, so we'll keep on trucking here. And I'll just flash up this guy here. I don't know if I can move that out of the way. I guess I can, yeah. So packaging strategies forecasts that brands will look to find out more about the impact of their supply chains and how they can optimize processes to reduce their environmental footprint. All right. So we know the green conversation has been going on for a long time, just being more environmentally aware, trying to reduce your footprint or the damage we're doing to the environment. But that's, I think, has started to become much more real. I think people are really starting to make decisions that are linked to sustainability and are choosing options that are the more sustainable options. So I'm going to just kind of give you two little things here to think about. And these are general statements about inspection technology. This is not, well, Baldwin does this and nobody else does. Okay, this is just, what can inspection systems do for a labels printer? Okay, so as I mentioned, at their core, they're all about finding variations and alerting the user to those variations. And what does that give you? It gives you the ability to intervene, reduce the amount of waste you produce. And if you can reduce the amount of waste you're producing, that allows you to start adjusting things like, how long do I run for a given order? Because historically I may be running at a particular waste level, but now with inspection technology and the ability to intervene and reduce the amount of waste I'm typically producing per roll, I can now get jobs done quicker. Okay, so I can actually reduce the amount of material I got to print to fulfill an order. But also with these systems, like the PQV, where it can actually give you real-time information about the pass and fail count that you have, when you're done. When you've achieved the yield that's required to fulfill an order, and you can stop the press and you can get on to the next job. So you've used less energy, let's say less material, less ink on that job than you might otherwise have done. It also allows you to actually gain back some press time, which increases the overall operating efficiency of that machine, which allows you to go do more work, right? So that's going to improve your sustainability straight away. Then on the back end, which again, I'll talk about towards the end of the presentation, but again, the idea here with our workflow is that if you know where the waste is, and you have a tool that can automatically stop a slitter or a rewinder or open a reject mechanism on a sheeting device where the waste is that you want to take out of your finishing process, you can run those machines faster. And the example here, this utilization of 30% is conservative. We've seen customers who use the full PQV workflow in finishing on rewinding devices get 30 to 50% improvement in their throughput, because they're able to run those machines at the speeds they're designed to run, which is 1,500, 1,800, 2,000 feet per minute, because they know the system is going to stop where the waste is so that you don't miss anything. Okay. So we'll jump into the Wizard IQ itself. Okay, so sorry, I tell a lie. I'm going to start with the PQV workflow. My apologies. So what I wanted to do here is try to just give you that high level. Here's the full kind of workflow. What are all the building blocks of a defect management workflow rather than just an inspection system? So we have the 100% inspection component, the PQV, and that's typically mounted on a printing press. It doesn't have to be. It can be mounted on an inspection rewinder, sheeting devices, other types of converting machines. But the idea of putting it on a printing press is that you kind of get information early in your process so that if you are generating print defects and you can remedy them, you do so that you can eliminate waste in your workflow. So in this case here, this user interface also gives you a little map of the defects as they are produced or as they're identified by the system. So if you've got a good label, it's green. If you get a bad label, it's red. If you get a repeating defect across multiple labels, you get an orange. If it's a defect that somebody has taken a look at and feel it's an acceptable defect, it will be marked yellow. So there's a lot in that. But what we're trying to do with the inspection system is provide you context. We're not just flashing up images of random defects. We're trying to help you kind of link that to the overall quality of the roll to try to understand, am I seeing just a random issue, or am I seeing something that's persisting? Am I seeing something that's just not going away? It's in a given lane that I need to investigate as an operator. Okay, so it gives you images of individual defects, but it also gives you that kind of high level, how's the whole roll performing, so that you can really kind of make those kind of statistical decisions when to get involved as an operator. So we're inspecting in real time, we're providing information to help the operator eliminate or reduce the waste, but we get a defect map, and that defect map goes into our defect database. And in the defect database, we have another product that is our edit workstation that allows you to then interrogate the database and look at all the roll maps and look at all of the defect events, and now start to make quality decisions or even business level decisions, like I said, where you're balancing out your risk here. You're kind of saying, okay, I've got a customer, they have a particular requirement around quality. I've got these particular issues. How much of this product am I willing to ship or not ship? But the point here is that we're giving you all the data to make informed decisions about, the amount of risk you may want to take on, or if you've got a customer that demands zero defects, to give them zero defects. Okay. So you end up with edited defect maps, we've got these quality decisions made. And then in the finishing, we have our control workstation, which can be mounted on a rewinder or a slitter or a sheeter, like I said, with a very simple interface. But the idea here is that you have a role map now where maybe most of the defects have been accepted, but those persistent zones of repeating defects need to be removed. Maybe it's because they're particularly objectionable, or maybe because they're nice and compact and densely populated so that you can take out a lot of waste or defects without really taking out a lot of material. But again, they're your decisions to make. You've got the data to drive those decisions. And the point here in the converting side of it is that when you make your decisions, you've made decisions based on real data that allow you to get to this commercially acceptable output. Maybe that's 0 defects, maybe it's 2% defects. They're your metrics you drive that help you drive those decisions, but we give you the data and the ability to act on those decisions with the system. Okay. So then we'll get into the Wizard IQ. So again, this is sort of the training wizard. This is the thing that allows a user to get access to all these tools to really use the product to its full. All right. So what I've got here is actually a little video, and I'm going to start up the video, but what I'm going to do is I'm going to pause it. I'm going to kind of manually kind of move my way through a couple of different points and talk to them. And then at the end of it, I'll just leave it play through in real time so you can kind of see what happens here. Okay. But what we've got in the middle of the screen here is our project wizard, our Wizard IQ, our one-step training wizard, where you enter the details that you need to enter to set up the system. Okay, I'm just going to talk about a couple of important things here. You've got a sensitivity setting zone, you've got a lighting preset zone. And one of the enhancements we've made with the new wizard is that we've made it a sensitivity based setup, and we have simple access to lighting presets to kind of take all the guesswork out of how to light a given product. And I'll talk about the lighting maybe first. The one thing with any inspection system is the term garbage in, garbage out. Okay, if you don't have a good image of the product that you're trying to inspect, you're not going to get a good inspection results. If you imagine you turn the lights off, system can't see any defects, no good. If you have the lights turned up too high and you start to wash out details, again, not a great scenario. So with the PQV installed, we provide a set of pre-faults. So we calibrate the system for different lighting conditions, and the lighting conditions are saved and are a very simple, accessible menu. And they're typically just standard, back, and reflective. Okay. If you've got custom jobs that require different types of wavelengths like UV lights or IR lights, they can also be added in and can be available. But normally we're providing light setups to deal with clear materials, highly reflecting or metallic type substrates, or standard opaque substrates like paper. And the idea is that the operator doesn't have to play with light levels. They don't have to figure out which lights to turn on. They're running a paper job today. The light preset can say paper. Or if they're running a clear film job, the light preset can say clear film. It makes it very, very simple for the user to choose the appropriate lighting and get the best result. On the sensitivity setting side of things, again, it's very customizable on our side, but then can become very, very simple or tailored to your needs. So it can be a case that you have one standard that you apply across the board. Every product you print has this level of performance you expect. You've got one sensitivity. It's a default, easy. You may have different tiering of customers that you print for, high-end demanding customers, people that have a simple job and have lower requirements. You can have high, medium, low sensitivity, or you may even have specific customers that have very unique demands, and you can create sensitivity files for those customers. And that's, again, the nice thing about the new Project Wizard is you can actually create a sensitivity for a given customer and then save it to the settings. So if you have customer X can be in that sensitivity list. Okay, so we get to the point where we've chosen our lighting. We know how rigorously we want to inspect the product, and so we begin. Okay, so I'm just going to move this along here to another step where the operator in this case is going to position a green box and say this is a label that I want to train on. So I'm going to zoom in here just so you can kind of see that. But in this area here, you'll see we've got this green box that the user has drawn around this particular label and say, okay, this is a label. I want to train on this label. All right. So what the user will do now is they will hit the train button. So I'll just move it along here again, and they hit the train button, and then milliseconds later, that label has been trained. And a lot of things have happened in the time the operator has touched that screen and taken their hand off of it. Okay, so I'll just quickly walk you through some of the things that have happened just by pressing that button. So the PQV has identified all the different codes that are in this label. So whether it's a QR code, a linear code, any type of code that is typically printed in the labels industry, the system can identify it automatically. So it identifies its type, it decodes it and grades it automatically. The user doesn't have to press any buttons to do with barcodes, doesn't have to define any barcode values or tell the system what it is. The system does it automatically. There's no training, there's no time required. The operator is just hitting the train button. Okay. The other thing that happens here as well is you'll see all these little gold boxes. And this is another feature of the PQV, which is it's object-based processing or inspection. And it's sort of a unique implementation of inspection that the PQV has that nobody else has. And what it does is it is able to identify every unique character or feature or element within the artwork. So it doesn't matter if it's a pharmaceutical label, if it's some graphics, it'll always be something the PQV probably hasn't seen before, but it uses algorithms that can find individual features and train each individual feature independently and inspect those features, all of them, thousands of them, in real time, all the time. And I'll talk about why that's important on the inspection side a little bit later on. But the point is, nobody does anything to make that happen. You press the train button, and the system does what it does. And it does it the same way every time, consistently, repeatedly. The other thing that happened when the train button was pressed is that the system automatically found every valid color measurement location there is on the label. So that would be these color blocks here, these color blocks there, any white area, any large element of text, anywhere that you might potentially use an offline color measurement device like a spectrophotometer to take a measurement. The PQV does this automatically. It finds all of the valid locations and it trains on the current values, the RGB values in those areas. And then when we go into inspection, it will look at every one of those measurement points on every label all the time, and it will check for a delta E variation based on the tolerance that has been set using the sensitivity. So it does it again without any operator input, doesn't require any time, doesn't require any training, and it is extremely rigorous in how it works, in that it does it basically everywhere where it's possible all the time. You can't do any more. Nothing else can do better. Okay. So then after we've hit the train button, we have a second step, which is operator will typically just take a quick look and say, okay, I'm happy that the label has been trained up. And then the operator will then press this copy button here, which you've seen highlighted, and it will then apply that setting to all the other labels automatically. So there's a section here where it trains up and finishes. All right. So I've done a lot of talking. So what I'm going to do now is I'm just going to let that video play right from the beginning here. So you see just how quickly that happens in real time. So I'm going to start right now, I think. There we go. So the operator is just positioning the box on the label. Then they press the train button, label is trained, then they press copy all, system is trained, done. Okay, so that took just over 16 seconds to complete. Okay, so it is very quick, it is very automated, it is automating some advanced features and functionalities that are have been typically very complex for an operator to understand and very laborious to kind of put into real practice in a production environment. We've taken all of that away and we've given something that is extremely simple to use and just inherently repeatable, predictable, consistent. It doesn't matter if it's your best operator on the day shift, if it's your new guy on the night shift, you're going to get the same result every time because all you're doing is hitting the train button, hitting the copy all button and going. It's that simple. All right. So what I'm going to do now is I'm just going to kind of break that down a little bit into just get on to the next slide here. So I'm just going to talk a little bit more in detail about some of those features that we just saw there in the wizard, because the real big enhancements for the PQV here are really how we have kind of maximized the kind of the functionality around delta E color monitoring and barcode. We'll call it verification or decoding and grading at various levels, but two very complex and powerful tools and capabilities that have become, I would say, very commonplace in your types of applications today. I think most labels printers sort of expect these functionalities now in inspection systems by default. They expect them to be kind of part of the fabric of the system, not expensive add-ons or things that require special training or classes. This should just be there. This should just work, and that's what the PQV Wizard IQ is doing now. So with this delta E color monitoring, it's sort of taking something that is available in the market. Pretty much everybody that you speak to with inspection technology will be able to offer you this functionality, but it's how we offer you this functionality is kind of the big differentiator. The PQV has had another version and still has this version of the color monitoring where the user can manually select a location and apply it and say, I want to measure color here, and I want to set this delta E tolerance here. That's still there. Other people have that too. The problem with all of that is that it requires the operator to understand how to do that. It requires the operator to take the time to do it. And because it's a human doing a manual process, it's going to be inconsistent operator to operator, and even a given operator probably will be inconsistent in how they apply their skill, depending on what time of the day it is and whether they're tired or not. So we're taking a very complex feature that I think all of you would want and taking it out of the hands of the operator, de-skilling the process, and also really making it much more comprehensive. So instead of an operator choosing maybe half a dozen measurement points, probably 1 point per color in the job, the system can automatically find thousands of measurement points in milliseconds. You press the button, it does it. And the advantage now is sometimes a color variation is not going to be across the board. It's not going to be the ink changing color. It might be some other part of the process that's breaking down and causing a color variation that's more localized. If you've placed one color measurement location on one side of the web and your issues on the other, you're not going to see it, right? So this implementation will measure color everywhere homogeneously as much as the structure of the image will allow, and do it in real time all the time. And that's extremely powerful. So if I just kind of blow this up here, what you'll see here is just in this corner, we've got the Baldwin logo. And what I wanted to show is that when the Baldwin logo, which is red, has shifted color, the PQV detects every instance of that shifting color. So you'll see that every letter in Baldwin has been identified as having a color issue, and every instance of Baldwin in the artwork, and if I zoom in here, you'll see that every one of the Baldwins, everywhere there's that red, has been identified, because in this particular case, it was an ink-based or a color shift in general, and it's been found everywhere. So we color code the boxes that we use for different types of defects. So in the case of a delta E color shift, we've got this purple outline, which again further helps to reinforce, what type of defect am I looking at in this particular case, okay? Then on the barcode verification, again, it's basically the same message in that we are fully automating how the system finds barcodes, how it knows what the barcode is, how it defines the value of the barcode, and then how it inspects the barcode. So if I blow up that area here, what we see is that we've got these 3 different code types, and they've all been identified. And again, another important thing here as well is that, barcodes aren't just the black structures, but there's also dead spaces or white spaces that are around codes that are also part of the code structure and that are important for decoding, grading, and evaluating codes. And the system just doesn't arbitrarily draw a green box here like this. There is a defined white space around that code that is part of the structure that is essential to identify and to measure as part of the process. And the PQV does that. So again, Operator doesn't have to locate codes, doesn't have to identify codes. The system does it automatically during the training phase and obviously when you're inspecting. Okay. And then the last kind of big thing in that training wizard that I touched on was the objects inspection. And again, we've got our more detailed label here. And if I just roll this on a little bit, and it's not very easy to see here, but if I just kind of go back and forth, you see those little golden boxes appear, and I can again zoom in and we can see it here maybe just in a little bit more detail. But what's happening is every character feature within the label is being identified to be inspected individually. And again, if I blow up that area here, we can see that same process happening just in a little bit larger field of view. So again, the main benefit of the object inspection is that it makes the PQV very, very sensitive or capable of finding issues within high frequency areas. So they can be in busy text like that, would maybe have lots of important information, can be in codes as well. And it allows you to basically avoid sort of the nuisance factor that you can often get with inspection technology, where you want to be able to see like the missing period at the end of that sentence because it's critical. But what you don't want is to see an ink splash that is the same size as that period somewhere else in the artwork. But what you're having to do is you're having to dial up the entire system sensitivity to be able to find that one critical issue in the noise of the hundreds of other small ink splashes that you're getting, which sort of makes the system impractical. It makes it useless because it becomes a nuisance for the operator. The PQV doesn't do that. The PQV treats content like the language, like the codes, differently than the non-content areas, or what we would call the background areas. And you can apply, and it does it automatically, but you can define how it does it to ignore things that are a little bit larger in non-critical areas, but to be able to have the power to find very small differences, but that are very critical differences in these higher frequency areas. And then just a little catalog maybe of some of the the different types of defects that the PQV can find. As I said, it can find things that we call background defects like hickeys and like spots in clear backgrounds, simple stuff. Of course it can. And the problem is every system can find the simple stuff. And when you want to find the difficult stuff, the critical stuff, sometimes you got to deal with a whole lot of noise that comes along with it because the system is just becoming sensitive to everything. And again, with some of the examples that you'll see here, like a filled in character or, an incomplete character, or, like this is a smear or something dragging through a text area, the system can treat those completely independently. It can have very high sensitivity to things that would be a critical failure to very sensitive parts of the artwork, but can play a little bit dumber or allow a little bit more flexibility for variation in areas where it's not so important. And then just a couple of examples of where you might install a PQV. So as I said at the beginning here with the workflow, we're typically installing PQVs on press. So in the top left here, we've got your pretty traditional inline flexo printing. And the idea of putting it on the printing press is that it gives you the earliest possibility to warn of some issues getting into your process. So if you can detect a defect as it starts, as it propagates on the press and address it, you'll minimize the amount of waste you've introduced, and you've captured the signatures, if you like, or the positions of the defects that have been created, so that in that workflow that I discussed earlier, you're able to see where those events are in the roles, and you're able to make decisions about what's good and bad, and then act on those decisions in an automated way in your finishing. In some cases, it makes a lot more sense to put a PQV on a rewinder. So again, for people that are probably just kind of looking into inspection here, if you have some demanding customers or certain artwork or certain types of products that are demanding or difficult to produce, and there's a need to kind of focus on a specific part of the portfolio of work that you do, often it makes much more financial sense to take an inspection system and put it on a rewinder. And that allows you to funnel work maybe from multiple different printing presses through the rewinder, and then just deal with, that subset of your overall production that really demands that higher level of scrutiny. And on rewinder applications, there's a lot of different ways that you can play with rewinders. In most cases, there's an expectation that you're not just going to find a defect, but you're going to allow the system to, back up to where that defective label is, so it can be removed by the operator. You can put an approved good replacement label on there. And then again, the PQV would also support even, stepping back from there and re-inspecting that new label as well. So you kind of get that, 200% inspection, whatever you want to call it, but you're kind of double checking that your quality process is working by verifying that the good label, is indeed good. Some other examples then, sheet fed applications, sheet transports, a lot, maybe more so in sort of security type applications, but again, the PQV uses different technologies, again, depending on the requirements. So you'll see this taller hood up here is what we call a line scan camera. So the camera is sitting high up in the hood here, and it's looking at a field of view that's close to the width of this hood. These systems down here are actually compact, and they're sitting very close to the surface of the substrate, and they're called contact image sensors. And again, they're a different type of technology. They are a camera, but in a different kind of configuration, and they're sort of like, think of your flatbed scanner on your office desk that you place a sheet down, and this scanning device moves up and down the sheet. In this case, the technology is fixed, and this is the sheet that passes the scanner. The technology is very interesting because it allows you to grab images at much higher resolution than you can do traditionally on a regular printing press. And again, depending on your requirements, can be a very good way to go about it. And then finally, just digital applications. So this is just a standard, or I think it's a domino press here, I'm going to say just a regular digital press, but there's situations where there's variable content being introduced. So digital presses can be purely digital and just print fixed content. You can have hybrid presses that are designed typically to produce variable content and otherwise fixed artwork. The PQV supports all of those scenarios, whether you're doing, fixed content on digital presses, where you're doing variable content. So if you've got variable codes that are being introduced and do some serialization, or have a unique feature on every product, the PQV can do that. It can check every code against a database of codes that have been presented to it and verify that they're all there, that they all passed, and if they didn't, provide you reports that you know what's going on. All right. So that's kind of the quick kind of run through of mainly Wizard IQ. Hopefully a little bit more information about how inspection systems can not just have become simpler to use, but you're getting simplicity plus additional power. Makes it easier for you to kind of maybe manage your workforce. Maybe you've got higher turnover and you've got training issues. This product in particular has become very, very simple to use, but it doesn't give up its power or its capability to be simple. It has become simple and much more powerful as well. Again, kind of lowering that barrier to entry. And again, the other side of it is, now that you've got a product that you can use in production, in practice, easily and repeatably, you get all those benefits that we've always been talking about with inspection technology, which is find the issues quick, fix the problems quick, and then track the problems that have got into your workflow and efficiently deal with them on the back end. And then it's a win. Okay. So I think that is the end of the presentation, Jack. So I can stop there and hand it back to you.
Wonderful. Thank you. So yeah, there were, a couple questions that did come in. So I'm going to fire off the first one at you if you're ready.
Sure.
And the first one is, most other systems on the market have delta E color measuring. What makes yours so special?
Okay. Yeah. So I think the specialty is in the automation. It's kind of taking the whole manual aspect out of the process. Like I said, the PQV has an older generation of that technology, that functionality, that is very similar to lots of other systems on the market where, you are ticking the box of, we have a product that can give you a Delta E color monitoring. The problem with it is it requires a user to take time to use that functionality and know what they're doing. And it means that you don't get a lot of coverage. You get a certain number of points that have been selected by the user, and it'll vary by user. It's that whole consistency thing I talked about as well. What the Wizard IQ is giving you is making that automated. So, again, I'm kind of repeating myself a little bit, I guess, but it's back to ease of use or simplicity. It's kind of consistent, and it's because it's automated. It does the same thing every time. So you know how it works. It doesn't vary from shift to shift or operator to operator. You don't have to train anybody to use it. There's nothing that you've got to touch as a user to take advantage of it. And it measures, I would say, I haven't really done the numbers, but anywhere from 500 to 1,000 times the locations of the manual versions. So it's a no-brainer, in my opinion.
Yeah, I mean, I would agree. That sounds pretty amazing and definitely makes it special. So the next question that came in is, right, the Wizard, it looks like an operator still kind of has to enter a lot of data. How can you tell that the Wizard's simplified?
Okay. So there, okay, you do have to enter a couple of data points, but the simplification, okay, I guess there's two parts to the simplification. One is, again, the whole color, barcodes, and objects, the fact that all these tools kind of just run. You press the train button, you don't go into the color step or the barcode step or the object step. There's not like this whole process that an operator needs to understand. You're just hitting the button and it does what it does. That's huge. Okay, that's fully automated. You're just telling the system to do its job when it's ready. When they're ready, it goes. And then the other parts that have become very simplified or become much more intuitive are things that are critical to how to getting the best out of the system. So it's lighting and it's the sensitivity profile. If you get the lighting wrong, garbage in, garbage out. If you get the sensitivity wrong, or if you are kind of left carte blanche, you go in, you kind of play with sliders, you change this value, you change that value. You don't know what you're doing. You've no control. You've got no baselines, and it's chaos. What we're doing is with the sensitivity settings, we are giving a structure behind the scenes to allow the system to be configured specifically to anybody who's on this call. So somebody on this call will want to have 20 settings because they do a huge variety of work, and they've got customers that are really critical about this type of aspect over here and that type of aspect there. Maybe most of the guys on the call are like that, but you can create that level of options or opportunity to kind of inspect these products as you need them. If you only need something that's a one-off, or if you only need a few levels of sensitivity and keep it very, very simple for the user, you can do that too. So really, you're in control of how complex or how simple you want that step to be. And again, there's a lot of people, as I said, that need a lot more complexity, variability, and that's fine too. But when you don't, we've got it. It can be extremely simple. Okay.
Yeah, I mean, that sounds pretty awesome.
Okay.
I mean, it's like I could be an operator, even though I'm definitely not qualified to do it, but the Wizard makes it sound pretty easy.
Yeah, and me too, I'm sure. Yeah, I think we both could be operators now.
Awesome. So I see one more question in the chat, unless anybody else on the call has their question, which feel free to pop it into the chat, into the Q&A section, wherever it is, we'll find it. And we want to get your question answered. But you spoke about objects inspection. Could you please, explain again why you feel that this is so good at finding the defects?
Okay, so I have to prove myself here. It's a tough crowd. So yeah, object inspection, it's sort of a complex thing to really describe, but I'll try to explain where the issue is for systems, and maybe that'll help. So we all know that a printing process has tolerances, it has variability that is present, and it's okay. Okay, so the one of the biggest ones is register. Okay, color variation too, right? You're trying to maintain, the process within some boundaries of, reasonable boundaries. So with color, it can be maybe just stay within 2 delta E. With register, stay, within, whatever. I'm trying to think now. US here now, 32nd of an inch, 64th of an inch, 0.1 of a millimeter, whatever it is. But you want to stay within those boundaries, and that's great. And you want a system that will let you know if it goes outside those boundaries, and the PQV can do that. But within acceptable print, there's things that move. Okay, so you've got 2 colors and they're kind of moving around just a little bit, but it's all good. There's no problem. And some systems, many systems, treat the entire artwork as one thing. It's an image, and it is what it is. It's what it was when the system trained on it, but it changes all the time. It's never exactly the same. And to accommodate that, systems have to build in little tolerances to where exactly all those features are living, because it knows those features are not all going to live exactly in the same place on every repeat. And over time, they're going to move around, and everything is still good, but there are differences that it has to ignore. So to ignore those differences, it applies what we call thresholds, which is basically, I've got this feature that's, my pinky here or whatever, right? And my pinky may not always be exactly in the same place. It's going to move around a little bit. So I'm going to say, okay, pinky can be a couple of pixels this way, a couple of pixels that way, up or down, and that's fine. But that kind of softens the system's ability to know if it's really where it should be, or if it's really the way it actually is meant to be printed, because it's allowing it to kind of change by some amount. What the PQV does is it actually takes this pinky, and then it takes this finger and that finger and this finger and that thumb, and treats them all separately. It looks at each one as an individual entity and doesn't care about how they are represented. I'm trying to point here up here, but it doesn't care how this finger moves with respect to this finger. There are tolerances that manage that, but this feature is the same feature all the time, doesn't matter where it is. And the PQV does not have to apply those tolerances for where is it now, and still is okay. So it's really the registration movement is the thing that can really dumb down systems' ability to find defects in high frequency areas. So the example I think I used at the beginning was like your missing period, right? You've got a dot at the end of a sentence, or you've got a period, like in a dosage piece of information, it might be 1.0 grams, and that dot is gone. And now it's saying, take 10 grams, Mr. Customer, okay? Which is obviously bad news. That dot is tiny. That dot, if depending on the font size, can be smaller than the acceptable register tolerance. Some systems end up masking out that dot, because that dot can be further away than it's physically big and still be okay. But the PQV will find that dot and will track it wherever it's going and make sure it's still the same dot as it was wherever it was when it was trained. And therefore, no tolerances are applied, and it is super sensitive or super capable of finding differences in those high frequency areas, which are the critical areas. And again, as I said earlier on as well, it treats those areas that way because it's content, it's information, it's codes that are critical. The background or the non-critical or very smooth areas where there's not a whole lot going on, it can be treated differently, and you can allow for larger defects to happen in those areas than in the most sensitive areas. And then that still, and I know I'm rambling here, but that still goes back to the whole notion of, I want an inspection system that is not going to drive my operators nuts. It's got to work. It's got to detect things that the operator cares about, and only things it cares about. And if you've got to dial your system up to 11 across the board for everything to try to find that missing period, you're going to be faced with 1,000 non-issues for every one issue you care about, and it'll get lost. And you'll get an operator who'll stop using the system because it's just driving them nuts. So, there's a couple of things there, but that's really the power of the object inspection. It's not the science, it's not the technology, it's not the IP. It's what does it mean from a use case. And what it means is I find something I care about while I ignore stuff I don't care about. That's the key.
Interesting. Thank you for that explanation. Glad we tested you on that one. So we did have another question come in while you were speaking, and that question is, with respect to the defect map, is there a way to predetermine a min/max quantity of grouping of good parts or of waste, particularly to avoid splices in a roll if a label replacement is not an option?
Ooh, that's a long question. Okay, I have to think about that. There's a lot of parts to that. So this, you have to actually give me the start of that one again. So there was, I apologize.
All good. So is there a way to predetermine a minimum or maximum quantity of grouping of good parts or waste?
Okay, so we'll hold it there. So in terms of predefining, so the system sensitivity predefines a lot of things like the size of the defect, the color variation, the register movement. Then there are algorithms that will look at the density of a defect, so the repetitive nature of the defect. So if it is repeating on every label, mark it as a repeating defect, so it's clear in the role map or the defect map. If you only want to track repeating defects that are intermittent, so happen over longer periods of time, but still have a frequency, you can tune the system that way as well. So most of our filtering is sort of done up front, so that what's sort of in the database is kind of the cleanest set of information that you can use. And then really after that, what you're trying to do is look for patterns in the maps. So there's nothing in the map that says that really address, I think that the question of, I need to make so many splices, so I want to know where I'm going to make all my splices. The system doesn't calculate the best way to, remove waste based on the splice side of things. But what it does allow you to do is analyze data that's pretty clean, and then to sort of discount all the random ones. So in the map that I showed, it was very easy to kind of accept the random defects and see where the clusters of repeating defects were, just visually, without even going in and clicking on a defect image and looking at the defect. You already know there's where I'm going to make my splice in this case, because I'm not going to stop for the 10 random defects. I can't put in 10 splices, but there is a good opportunity to put in one splice here by taking out the beginning of that first set of repeating defects and going to the end of the second set of repeating defects. So we don't have the ability to kind of do that calculation. I have this amount of splices in this case, and part of the issue with that is it's so complicated. It kind of varies job to job. It varies customer to customer. But if the person who sent in that request or question wanted to follow up with me on that one, I would like to have a conversation about them, because that's not the first time that's come up, and it'd be interesting to understand their specific need or interest around that function. I'd love to have a conversation with them.
Absolutely. Well, if you don't mind, in the post-event email that we send out, can we include your email just so that person can reach out individually and have a conversation with you?
Yep, absolutely.
Awesome. Thank you. And that was kind of the last question that came in. So, on behalf of myself, because I have a good time talking with you, and on behalf of TLMI, John, thank you, Baldwin Vision Systems, for hosting today and for supporting TLMI. If anybody else on this call is interested in getting more involved with TLMI, getting your company involved with TLMI, or to host your own lunch and learn just like this, please reach out to Dale. Dale is TLMI's engagement director. Dale's email is Dale, DALE, .coates@tlmi.com. We hope you enjoyed today. I had a great time, John, right? We've had a few meetings. It's been fun talking with you. I hope your travels are going smoothly. I know you're in the middle of a hotel doing this for us right now, so we really appreciate it. So stay tuned. You will get an email with a survey along with John's information in there if you want to reach out to John independently, have that conversation. Trust me, John's a fun guy to talk to, so take advantage of it. And John, with that, is there anything you would like to say to the rest of us on the call?
No, you got the big one is sort of definitely reach out. I know there's a lot of information that kind of can flow out here, and maybe some things don't come to mind right away, but if you watch it back, or if something pops up, if you want to have a conversation or get something clarified, absolutely, please reach out to me. I'd be delighted to have the conversation. Okay, no problem.
Perfect. Well, thank you so much, John. Like I
Mhm.
said, it's been a pleasure talking with you. Can't wait to do this again. This will be fun. And yes, we will get the recording out to everybody. We'll check your emails for that post-event email. And John, I'll be talking with you soon.
Yep. All right. Thanks very much, Jack. And thanks, everybody. Have fun. Take care.
Thanks, everybody.